So without further ado, we will get started here. Want to thank everybody for taking time out of their day to join us. We're going to be talking about managing the office of the future. It's going to be part of our quarterly customer connect event. So we want to bring a lot of our customers on and just kind of showcase what a lot of you are doing, some new use cases that maybe you guys have refined and come up with and utilize in interesting ways. We're going to talk about the remote workers, which a lot of you already know a little bit about, but also our brand new feature called path analysis and how that's being utilized. So for those of you that I have not met, my name is Stephen Prugar. I am a customer success engineer over here at NetBeez. So it's very nice to meet everybody and everybody who I have worked with. It's good to see you guys as well. And the two use cases that we're going to discuss, one of them is from a company called Marlette Funding. It's one of our customers brought on board actually during COVID. They were founded in 2014, big time lender, like $7 billion in loans and a lot, 350,000 customers. That's a lot of customers, and they have a really interesting use case. The other one is going to be centered around the path analysis feature that we just released. Talking about how that's really filling the gaps, a lot of blind spots that are out there right now. So diving into the remote worker situation, about 9 out of 10 organizations had to implement either full remote or, in this case now, a lot of times hybrid remote working since COVID-19. Just under 2/3 of those companies have indicated that one of the barriers of maintaining remote workforce is application performance, especially from remote workers, and where the problems lie, whether it's the application or the user itself. A little bit over 2/3 of the tickets being open nowadays are by users and not the IT team. And just a hair under 90% of the knocks that were surveyed were saying that they have a lot of blind spots in their current set of management tools, especially the visibility into the home network. So most of you that I've talked to have expressed that you're either currently fully remote or at least in a hybrid scenario. So that's going to be here to stay, especially for a lot of positions that you can do a lot of your monitoring or day-to-day job function remotely. And that's going to bring some new challenges to not just the NOC, but also the help desk. And we're seeing a lot of that over the last year. So some of the blind spots, you don't have SNMP pulling, you don't have net flow generation, and you don't have packet capture. That's very clumsy to try to packet capture remotely in many cases. So the performance tools or insights we need is going to be application performance to the remote user, ISP availability and the performance of the ISP as well. And then lastly, VPN utilization and the performance over the VPN. So the new tools that are required, active, proactive, the whole slew of what we offer in a remote form. Endpoint-based monitoring basically is what we're doing. And then adding in path analysis, which we're going to cover a little bit later for trying to ascertain where the problems are from an internet standpoint. Having that raw data for troubleshooting is absolutely key. So many people have expressed having that visibility, having that 5 second by 5 second data is so critical in trying to find out where these problems are coming from and how to solve them. And then home Wi-Fi performance. I think that's actually one of the biggest areas of struggle right now is understanding how well the Wi-Fi is performing and what are some outside influences that could be impacting. So we have 2 agents, Windows and Mac, and it's really important to note that we develop both because we're not going all in on either. We're equally supporting both or developing both at the same time because companies like Marlette Funding, for example, their funding was like 80, or their split's like 80-20, for example. Some cases our customers could be definitely more Mac shop than Windows shop, so having both is key. And then delivering things such as latency, jitter, packet loss, MOS score, which is really useful, especially for your remote call centers. And then having your full slew of proactive detection, speed tests. In some cases, you can still do iPerf if you're connected to a VPN. And then the next step is going to be the Wi-Fi section. So the metrics, the connection, what are the local SSIDs? Is there channel saturation? Is there disconnection issues? And we even take it one step further, and we're going to give you some NIC information. So not give you information on the driver information. We support the VPN. You can see the IP addresses listed as well. And when you cursor over the NIC, you can even see like what the vendor is. In case of the VPN, you can see what the vendor is for that as well. So circling back to Marlin funding. So as soon as COVID, broke out in the States in March of 2020, they had to go remote like everybody else did, right? So they had a mixed environment, like I said, it was like 80-20, give or take. Let me go ahead, mute there. Roughly 80-20, and they did not have really much visibility for people working from home. There were a lot of connectivity issues. They didn't have a big window to solve a lot of these problems, and it was really affecting productivity both on Knox and the end users as well. So the solution was to deploy NetBeez on their laptops and desktops. That gave them remote access to view the performance of the laptops or desktops, allow them to have visibility on how the product's performing to all the web applications, and also identify some ISP related issues, some connectivity related issues. And that has gone a long way in really increasing productivity to the point where we've met with them probably about 2 months ago, and they've said they're staying remote and they're just going to have hybrid for people who want to return because they're fully able to handle it now at this point. So let me jump over to, let's do mine first. So this is running my laptop. So the laptop I'm presenting on is actually this agent. So you can see I'm not wired, I'm wireless. You can see, I'm on a Wi-Fi 6 NIC, right? You can see the VPN I'm connected to. I'm using Viscosity VPN back to the office. That's our office IP. That's my public Comcast IP. I want to show you this, and we'll go over to the Wi-Fi section. So this is the latency, jitter, and MOS. Let me bring up the participants in case anyone else tries to join. There we go. So you can see to Zoom. So we're running this on one of Zoom's East Coast servers. I'm pretty solid. My jitters, it's good. It doesn't hit above like 25. My MOS score has been like a solid 4.4. So everything's good. And then there's this guy. This guy decided that he was going to take a trip to Italy to visit family. So his performance to the East Coast Zoom server is not so good. And we actually did some troubleshooting on this earlier. So I'm going to overlay the same time period here. So he's typically in like the 200 range with latency. It's not too bad, but this was really bad. So his latency, and I'm actually going to extend this a little more, was in almost the thousands. His jitter was in the 2000 range, and his MOS was like solid 1.0. It turns out, and I'll show you this in the path analysis here in a minute, that it was actually related to the Airbnb that they're staying at, and the Wi-Fi was just really bad. So I think they're connected to their phone or something like that. So you can see it's definitely smoothed out a fair bit. It's not great, but I was just on a call with them earlier today around 11, and honestly, it was very doable. A little delayed due to the distance, but it was actually very doable. But what we found out, and I'll give you a really quick sneak peek here. So we're going to go back last 4 hours. I think we're looking at 9-ish. It was, oh wait, I need to do last day. The last 4 hours, we're not quite 9 o'clock there. There we go. Okay, so let's cycle in on, I think that was from like 8 to 9. Here we go, 9:10. There we go. So what we saw, let me actually full screen it so you guys can see better here, is we had issues right here. So right out the gate, right when like its first hop, we're almost 1,000 millisecond response time. So that's a solid like 1 second plus delay, actually higher than that. So that's when we realized that the issue was immediate. It was right at the very beginning of the network. So once he changed over, when did we change over? I think we changed over about an hour or so later. I think it got a lot better. Yeah, so you can see here, these are a lot. Well, of course, only hit one here before it didn't hit its destination. It was required more than 30 hops. But you can see here, it was significantly better. Just going on through the hours, we were definitely doing a lot better than what we were at, say, 9:15. Yeah, that was not good. So we definitely have gotten significantly better since he switched over. And then we're going to jump back over to here, and I'll re-full screen this so everybody can see. Okay, nobody else is joining. The other part is the wireless section. So I already preloaded this. This is all the SSIDs in range. You can sort by link quality, for example. So you can see mine HOV, that's me obviously, is going to be the best. Overall, same thing with signal strength. You can also sort by channel utilization. So for me, not super needed because I'm more in the suburbs. But if you're like in the city, like downtown Pittsburgh, which is where NetBeez is at, you would have a lot more networks in range, and you could potentially be looking at channel saturation, especially if you lived in an apartment building. So that's one thing that you can use to help isolate some issues. Um, you can also see what connection type they're on. So here you can see I'm on a WPA2 personal, which is really cool. So if you have like an SLA that somebody can't be on an open network, you can also see that here as well under the agent section, which is really cool. So you can see, make sure everybody very quickly and easily look to see if people are on the correct kind of connection. And then you can go here. So this will show you the connection history, the history of the link quality, the signal strength, and the bit rate. So if there's a bunch of like red and green, so something like if you had a bunch of these, for example, that would be indication there's a connection issue, right? So I only had one today. That was when I was upstairs in bed, so not really a big deal. And then it switched access points here. So I have a couple of APs around my house. But overall, it's been very stable, very solid. What you don't want to see is a lot of drops and a lot of dips and the signal strength tanking all the time. That would indicate that if somebody is experiencing issues, it definitely could be related to their Wi-Fi connection. So now that I give you a little bit of a teaser on the path analysis, let's actually talk a little bit about it. So with NetBeez, we have the remote agents we just talked about. We have all of your network agents, which are physical agents, virtual agents, Docker agents. In some cases, a lot of times Docker also is in the cloud where you can spin up things within AWS. And then you have your SaaS applications, your cloud, and your voice and video services. So when you're running these tests, right, you're getting the total trips performance, right? It's more of an average or aggregate. What you're not getting is the step-by-step information that happens from point A to point B. Sure, you can run a trace route, which I'll show you here in a minute, and that's one run, and that's kind of what we're trying to solve. So when a user reports an issue, the first thing you do is you take a look at the network, right? You look at NetBeez or whatever other things you have at your disposal to see, okay, is it a network issue? Okay. Then you look at NetBeez and say, okay, let's look at the other agents and see how well they're performing to the application. Let's look at other remote users. You're not seeing anything that's actually popping up, and at least nothing consistent. You might see one or two pings that have a little bit of a higher round trip time, but it's so inconsistent and so sparse that you don't know where the problem is. You can't prove it's a data center, right? You can call them up and complain, but it's going to fall on deaf ears. And a lot of times you have some issues with verifying if it's, can you change the routing? Is it something to do with the routing? Once it hits the edge of your network, you don't really have say or control in most cases on how that connection goes out to the internet. So again, that's why we run a trace route, right? You can do it from command line. You can do it from NetBeez anywhere from like a few seconds to a few minutes. You can do it within the console. You can do it ad hoc. You get one run. Overlaying multiple runs will require like copy, paste, export graphing, and be very cumbersome to compare multiple runs. There's no aggregated data. You're only getting information on a per hop basis, but it is good for one-off ad hoc troubleshooting, especially if there's an ongoing issue that is going to be widespread across the board. We do see a lot of people have a lot of uses for that, as well as on a product detection basis as well. So those are kind of the two main use cases. Now, the key additions that path analysis brings is you're going to get 20 flows and aggregated and disaggregated views, IP addresses, and reverse DNS if that's available. The RTT is probably one of the biggest things. You're going to get that on a per hop basis, and you're going to get a bunch more averages and all that stuff with all the runs in the historical data. You saw earlier with the color coding. So red means it's above 150 milliseconds and orange is above 100. So you get that information as well very quickly. And then you get the autonomous system number, the AS name, the geolocation, etc. Now, this is, I'm going to show you this a little bit more in detail. This is more of a data center test, but here we have my router and my switch, then my router, right? So this is my infrastructure. And then it hits Comcast, the local ISP here. Then it goes out to the internet, then it goes to the data center, then it goes to the destination. So previously, you would have access to this, right? Depending on if it's your data center or what you have deployed in there, you may have some information here and then you have information here. So the path analysis is really giving you a lot of this, and then some of this if you didn't already have this available. And a lot of this information, even if you did, a lot of this information that you're getting here will help prove where the problem is, and also show that you may not be able to fix the problem overnight. It may take some time. So let's actually look at an example. Which one? Here we go. Okay, so this is very similar to what I had before. I'm going to go ahead and maximize it, and I'll go ahead and I'll show the nodes for now. So right here is where it leaves the general ISP, and then this is going to be generally your base internet once it leaves out in here. So what's really cool is if I say click on this node, this happens to have all 20 flows running through it. It's not always going to be the case. It may break off in a couple of different paths, but you can see minimum, maximum, average, median. What's really cool is that if there's a couple outliers, you might be able to keep an eye on that and then report something to Comcast or whoever owns that node. In this case, it is Comcast, and let them know, hey, look, we're having some issues with this IP, this node, and I can show you every now and then it just spikes really high. Same thing with the general internet, depending on who owns it. In this case, Comcast also owns this one as well. But what's really nice is that this will show all of those little hiccups that sometimes pop up that are hard to identify. They're going to pop up in here. And you're going to be able to see all the different paths it takes from my Unraid server over there all the way to google.com, which they have servers in Pittsburgh, for example. So if there are any issues along the way, you'll be able to see those. You can highlight these based off of round trip time averages. So I just did 20. All these are below 20 except these couple. You can also highlight by partial or full IPs. So if I want to do 96 dot, which is Comcast, it'll highlight all those nodes for quick access. You can even highlight, let me click on a couple of these here. Come on, there we go. So if I click on a couple of these, it'll highlight them. But what's really cool is when you go to the default view, which is the aggregated view, it'll hold it. The same thing with ASN, although for me to Google, there's not a lot of fun information there, but also DNS, it'll hold these all the way through. So when you are trying to highlight a run, you'll be able to see in all different views. You don't have to retry to find how that run went. So I'm going to go ahead and clear that out. But yeah, so now this gives you pretty much as close as you can to full visibility from your network all the way to the application. So you can use this whether you're monitoring applications, you can use this to monitor your data center, you can use it to go building to building, especially for companies that are ISPs, that's very useful as well. We have a lot of customers that are providing services in that capacity as well. What's really cool that we're going to be bringing in 8.1, and I'll just giving you like a sneak peek. Obviously things can happen, but what we were planning for 8.1 is being able to click on multiple, so 2 of these nodes, and being able to overlap them onto this graph. So you can then essentially see how 2 different runs actually overlaid over top each other. It'll be color code 2 different colors. Right now, what will happen is when you click on this, it'll actually show you, like if this was like hop 6 for one run and hop 7, it'll color code and underline which one was which. You'll get the average statistics for both. So that is really, really, really cool. And then you can go back all the way up to a week. So you can go up to a week ago. And then as you saw, I was dragging this through and I was selecting different hops and everything like that. But now with this, you're going to have full visibility, a lot more than what you had before. When it comes to the traffic goes out of your network to its destination. And it will be coming to the remote sensor very soon. 8.1 is our current launch date for that. It is currently live on the Mac sensor, so do note that. And with that, that is it. We're coming up right at 20 minutes, so that was perfect timing. We're going to go ahead and open up a Q&A session if you guys have any questions. I will stop sharing.